Good morning, everybody. Thank you for taking some time to hear what we are all about here at 5E Advanced Materials. Okay, so 5E Advanced Materials. So we're a little bit different. So in the sense that yes, we're playing into the global energy transition, and yes, our product is a critical mineral, but we're actually mining a product called boron. And boron, as it's converted into a product called boric acid, has a lot of end uses in not only the global energy transition, but food security and also national defense. So just to give you an idea of kind of the highlights of what we are. So we're dual listed on the NASDAQ and the ASX. The rationale for the ASX is about 10 years ago, a group of Australian investors found this project. We're located in California. It's a little bit of a misnomer in that we're a fully permitted operating mine in California. We happen to be in a very mining-friendly jurisdiction in California, so it goes into our favor. But the group out of Australia raised a little bit of initial capital, drilled out the resource, finalized the overall resource numbers, started to put CapEx numbers around the project itself has kind of evolved a little bit. Originally, it was going to be a borate play with an SOP, sort of co-product to generate hydrochloric acid as part of the feedstock. We very much have simplified the project now. So we then, back in 2022, listed on the NASDAQ as a U.S.-based asset. We re-domiciled into the U.S. to sort of unlock the capital markets in the U.S. We are planning on operating across the value chain. So in the boron market specifically, you've got big miners, but then we're very dependent globally on China and Russia for the processing. So these advanced derivative materials, things like boron nitride, boron carbide, all of that stuff is processed in either Russia or China. As an example, boron carbide, you'll know as the commercial name Kevlar, so body armor and tank armor, 100% of that is globally processed in China. So even in the U.S., where we sit on the second largest boron mine, and I'll get into that in a second, that's owned by Rio Tinto, all of that product gets put on a boat overseas, processed to be bought back by nations like the UK, the US, and Australia. We are sitting on a large-scale resource, so we have the ability, and we are taking a multi-phased construction approach. We have the overall ability to scale up to 450,000 tons. That gives us, at that run rate, still a 31-year mine life. We're building this in phases, so what we're calling commercial phases 1, 2, and 3, off the back of the small-scale facility, which we've already completed and is now producing boric acid. It is the largest known conventional boron deposit outside of Turkey. There's 4 separate sets of borate deposits. Colemanite is the most commercially viable. The easiest way to explain it is, in a borate deposit, you either have calcium salts or you have a silica-based ore body. So if I put 2 glasses of water in front of you and I gave you a handful of sand and a handful of salt and you dropped it in the water, the salt would dissipate, the sand would sink to the bottom. That's how you have to think about processing colemanite. It's very easy to take it from its ore body into a refined product. We have the added benefit of the way we're mining. We're actually in situ leaching. So when the product comes to the end of our infrastructure, we already have a second derivative product in boric acid. On top of that, because we are in situ leaching, we do have lithium that comes out of that. It is not a primary driver of our business. We are not a lithium company. We will have some lithium that can go to partners and will help our economics, but we are not focused on that. We are focused on building what can grow into the second largest boron mine in the world outside of Turkey. So essentially the market is an oligopoly. Rio Tinto has about 20% in their U.S. borax market of global production. Turkey, through their entity owned by the government called Eti Maden, has about 65% of global production. They also sit on 72% of the world's reserves, which means as pricing goes and ability to put product into the market goes, the global market is highly dependent upon Turkey. And that's for things like items in the energy transition, global defense, and even food security. I talked about our stage execution model for delivery. And so we spent previous 2.5 years building a small scale facility that has the ability and is in the process of scaling up to 9,000 tons per annum. We are now starting FEL2 for commercial phase 1, which has a price tag of about $380 million. It gives you about a little over $100 million in EBITDA, and then we can build this scalable model from there. So just to give you a little bit of an idea of what the boron market is all about, when you take a look at boric acid, which is the term in which the overall market is referred to, plus all the derivative products, we're approaching $5 billion in the market today. There's very much a high barrier to entry, as I talked about. There's 2 companies that pretty much dominate the global boric acid market. There are some South American companies that mine borates, but they mine a form called eulousite. It has a lot more heavy metal salts in that and is mostly used in agriculture. So it's used as a soil conditioner. It's sold very cheaply, applied in mass quantities, and that's not a market that we ever expect to chase. Really, where the secret sauce is in the boron derivative market. So boric acid is considered a second derivative product. When you go into elemental boron, which is used in rocket fuels and rocket propulsion, that's a third derivative. It's used in things like ceramics and satellites and chips and space technology. Those are the derivative products will far outpace, the demand for those products are going to far outpace supply. So we're coming into the market at a really critical time. If you look at this graph here on the left-hand side, focus on the gray boxes, right? So the market for boric acid today is somewhere around 4 million tons. Most of that is what we call traditional applications, so ceramics, cleaners, fiberglass. Then you get into things like fiber optics. And then you get really, really cutting edge things like pharma applications, permanent magnets. So all the permanent magnets in vehicles and wind turbines are a neodymium boron permanent magnet. So the chemical symbol is NdFeB. So it's 2 parts rare earth, 1 part boron. There's no substitute for boron. And then you can see where all the growth in the market is coming is in the decarbonization sector. So again, it puts us in a really good position as we move forward. As the world needs more supply, some of the supply is being curtailed, we come in. Looking back over the last 12 months, we've accomplished quite a bit. So about this time last year, we refreshed our SK 1300 technical report, gave project economics, gave timeline, and that met with a very positive response to the market. We had one final condition under NEPA to get our EPA approval. So we had been in possession of our EPA permit, but we had to clear conditions. The last condition that we were looking for was authorization to inject. So essentially what we wanted to do was to be able to test downhole pressure. So we got the ability to do that in October. We finished the project fast, within budget and faster than expected. And then right before Thanksgiving in the U.S., we were given our authorization to inject. So we inject a diluted solution downhole. It sits in the ore body. It dissolves the ore body, and then it comes back up, and it's use the laser. Sorry about that. It gets held in these little holding tanks right here. So we fill up those holding tanks with what we call a PLS, or a pregnant leach solution. That's where the boron and lithium containing minerals sit. We then ultimately run the boron through this crystallizer here, and out that then connects to a bagging unit, and away we go. So our facility is fully commissioned, fully permitted. We are operating. We produced our first amount of boric acid back part of April of this year. We are starting to now amp up the run rate so that we've got more product. That product then goes right into our customer qualification process. We've spent about $72 million to date, but we are now kicking off this customer qualification process, which will allow us to then lead into offtake agreements. Where are we going to go in the next 12 months? So you can think of it from 2 ways. You can think of it as both plant optimization and corporate activities. So our initial plant is operating and we're collecting data every day. We know what we need to know about the well field talking to each other, dissolution rates, saturation points, what the head grades are when they're coming out. The whole point of us building this small scale facility was very similar in that we built it to prove that we could mine the ore body, which we've been able to do. We've built it to be able to show that we can produce boric acid via in situ leaching. We've done that. And every day that we run the plant, we're getting more and more data. That data then is going to be fed into our FEL 2, which Fluor kicked off earlier this month. We're now also at a point where, because we've got our operations happening, we're looking for ways to drive down our operating costs. As we have more and more product that goes into customer qualification, later this year that product will then start going into the spot market. So we'll be recognizing revenue by the end of the year. And now we're also looking at ways of how do we ramp up that production. So the facility was initially designed for 2,000 tons. We took time last year while we were finalizing the last EPA condition in an effort to look for ways to scaling up. The back end of the facility can actually process up to 9,000 tons. So we have the ability to now scale up to 9,000 tons, which will give us more product to sell. As I mentioned, we're in the middle of just kicked off FEL 2 engineering. The data collection and FEL 2 engineering will get us to a feasibility level document. We are in the process of feeding product to customers, which will then allow us to start putting offtake agreements in place. And we have defined our project financing. So traditional equity markets are always there. We did a capital raise at the beginning of the year. We brought in $17.5 million of fresh equity. We are in the process of also looking at non-dilutive ways, so royalty agreements, customer prepayment agreements. We are heavily reliant upon the U.S. government, specifically under the Department of Defense. So we decided last year to pivot our strategy and say we're not going to chase Department of Energy money because we're not a lithium company. We don't qualify for the ATVM program in the United States. But we are listed as a critical material for the Department of Defense. And since most of the derivative products that are being purchased by the U.S. government today are in some way, shape, or form incorporate boron, we decided to pivot, and we've got all of our funding requests, grant requests in with the Department of Defense. Now, the fact of the matter is we've got an election here coming up, so we can think of it as a guidepost. All of the funding from under the Defense Act has to be delivered and appropriated by essentially November 1st. So we do feel very strongly that we're going to be able to announce to the market a significant component of the government finance here either later this quarter or next quarter. Similar to the UK Infrastructure Bank, I have a lot of familiarity with that from my time at Sirius and Anglo. We have something similar, which is the U.S. Import-Export Credit Bank. That is specifically designed for work streams that are lessening the dependence specifically on China. So essentially what it is we'll go out, we'll get our project finance package put together. You can think of any of the normal players, the Appians, the Orions, the Sprots, and they will come in and they will backstop that loan on a dollar-for-dollar basis. And so we're in the process of the due diligence phase right there. Government funding focused mostly on Department of Defense. We've got 2 large funding applications for grant money at the tail end. We are in the process of getting a letter of support for the Import-Export Credit Bank, and we happen to come across a Department of Energy grant that allows us to work and work on our lithium extraction. We did put in an application thinking we're not a lithium company. We got invited to apply. We then got into the final round, and now we're starting to hear on that. But that's not part of our funding strategy moving forward. For time, let me just kind of jump into the market. So we do have a play in EVs. We don't have so much of a play in batteries, but in every electric vehicle you have a ferroboron chassis, right? So boron has a high tensile strength and it's lightweight. So you're seeing ferroboron chassis being incorporated. The permanent magnets that turn those motors, again, that's an NdFeB permanent magnet. Acoustic insulation, heat insulation, even the touch panels in all vehicles has boric acid as an input. Your iPhone, for that matter, Corning has a patent on your iPhone screen which is called Gorilla Glass. That has boric acid input into it. Global energy transition, the turbines for wind turbines, that's all fiberglass. The borosilica glass on all solar panels, that has boric acid as an input. Boron also happens to be one of the most essential micronutrients on the planet. So every farmer, whether they're a corn farmer in Brazil or a soybean farmer in the United States, they're incorporating zinc and boron in some capacity. So there's a whole food security angle that we haven't even begun to dissect. I come from a specialty crop nutrients background, so that's also an exciting opportunity for us. So traditional boron markets, things like detergents. You'll remember the old Borax laundry detergent. That was literally how Rio Tinto launched its U.S. borax mining operations. Micronutrient, widely accepted. Ceramics, mostly in kind of space technology. But the green energy transition is really where we're seeing the growth and the expected growth. I mentioned the market is about 4 million tons today. We're expecting 1.6 million new tons coming online. That's a problem. Rio Tinto, as I mentioned, is responsible for 20% of the global production, but they've decreased production year over year for the last 4 years for one simple reason. The mine is at the end of its life. It's been operating for 98 years. They're at the edge of the open pit deposit. They're getting less pure ore. Their operating costs are going up, so they're producing less. That we then enter into the market at just an absolute fantastic time. Logistical advantages, because we're in the central Mojave Desert, we've got access to the BNSF Railway and two interstate highways that essentially cut in between us and the railway. We're right near the port of Long Beach, so we've got bulk loading opportunities. We are in an area where there is more stability than some of the other mining operations producing boron. By the way, there's only 5 other prospective boron deposits around the globe, and of those 5, none of them have environmental permits or mining permits. So when it comes to new supply coming on, the name of the game is 5E. So we do have the ability, and ultimately the reason we call ourselves 5E Advanced Materials is we will be processing advanced material and derivative products. So we have the ability to mine it, refine it, and sell it to not only the U.S., but our friendly nations as well. And just to give you a quick idea before I'll pause and we'd open up for Q&A, we're doing things a little bit different. So we're not doing open pit hard rock mining. That's what Rio does. That's what the Turkish government does with their Etimaden deposits. We're using proven in situ leaching techniques, just like you would do with uranium, just like they've done with potash. So you inject down, the fluid dissolves the ore body, you extract it back up, you go through the processing system, and out the back comes crystallized boric acid. The key here is us simplifying production and processing. Because our borates are already coming up in solution, we don't have to induce them into solution for conversion into boric acid. So we immediately skip 2 steps here. We can then dry it, bag it through our system, and it comes out refined product at the back end, ready to go to a customer. Whereas what Turkey has to do is they've got to mine the hard rock, they've got to ship the hard rock to China. China then has to introduce it back into solution so they can create the boric acid. They will also then process it into derivative products, where then in this case it gets shipped back to the U.S. and then ultimately to the customer. So we're cutting out 4 steps in the supply chain. We're eliminating single points of failure, at least for what the Department of Defense views as a problem. We were successful last year in getting boron language listed in the National Defense Appropriations Act, which means they have to have traceability starting in 2026 where all their boron derivative products come from. So that's a nice step in the right direction for us. So just to sum up, fully integrated business model from mineral to application. The market is small. The new deposits are even smaller. U.S. investment into clean energy is a great tailwind for us. We're mining the easiest form of the borate family today. There are other forms of borates that actually don't have commercial processing solutions yet. That further narrows down the market. Solution mining puts us in an ability to minimize footprint and environmental impact. We've got a streamlined domestic supply chain with our customers in the U.S. and in Europe. and we are well diverse. We've got well diversified end users as part of our overall model. I think I hit it right on time.